topic about theory of intervals. Let's move on our topic. Here is the information about intervals. Intervals are likewise defined on an arbitrary totally ordered set such as integers or rational numbers. The notation of intervals is considered in the special section below. So here's the definition of intervals. Real intervals are the set of real numbers that contains all real numbers lying between any 2 points, two numbers of the set. Real intervals play an important role in theory of integration because they are the simplest sets whose size, mere or length is easy to define. Here are some notations of intervals. We have rotations, roster notations. Roster means set notation 3, 5, 6 up to -1, 0, 1, 2, 3 up to so on. Set builder notation x such that x greater than 0 as a set builder notations our intervals. And here is the real interval notations -2, 5. And here is the open and here is the close interval means -2 less than x less than or equal to 5. Here is the interval notation and set notation also said that. Example x greater than 5, how we define in interval. So first we define as an interval notation, then 5 as x means 5 up to infinite numbers is open interval notations. X greater than 5 means 5 up to infinite numbers. X is define any number in algebra. Note the sets of numbers in interval notations are always read from left to right as you would move along a number line. Okay. Interval notation position has two positions, the lower bound and the upper bounds. Here is the basics of intervals. 4 mean lower bound, first number, lowest possible x value, and 12 is an upper bound, second number, highest possible x values. Okay, understand? All three methods together. Here's a handy table showing all three methods. The interval is 1 to 2, from 1 including, not including, tab, and inequality. Here's one inequality, x greater than or equal to 1, not including, we define x greater than 1, including 1, x including 1s defined here, x greater than or equal to 1. Okay. Okay. X greater than or equal to 1 means 1 involved in close intervals sign, greater than or equal to, and greater than x greater than 1 means x involving but not involving 1, inequality. And number line, here we define a number line. Here is a number line of x greater than or equal to 1. It means 1 involving in this radius. Okay. And not even involving signs, here a circle, it means not involving a line, a number 1. 1 is present and 1 is not present, we define here. Here is an inequality sign, and here is the inequality sign means involving and not involving. And interval notations here means 1 involved in number line and radius, and 1 between two intervals and not involving 1. Okay. To 2 not including 2, including 2, including x less than 2, less than means not including, and less than or equal to 2 means including. And here's interval notation means not including, and here means including. This sign will represent a number including in radius of convergence. Okay, let's move on. Example, the interval 2 to 4 includes numbers such as, here 2 and 4, all the numbers between 2 and 4 are here on the interval of convergence. 2.1, 2.111 into 1, 2.5, 2.57, 2.5, 2.8, 0001, pi, 7 by 2, 3 point up to 3.7937 approaches to 4, and lots more numbers between 2, and here the interval of convergence between 2 and 4. This means 2 present or not present involving, or 4 involving or not involving in this interval. And this is the very easiest example to understand interval between two numbers. There is the interval 1 up to 7th interval between 2 and 4. There is the interval between 2 and 4. Okay, so basic concepts. What is the interval of convergence? The interval of convergence means the set of all points for which the series converges. Means set of all the points for which the series converges. Example, we learned that 2 and 4 between interval of convergence. So here is the example. Here is the number line x-axis. Here is the numbers between, example, -2, -1 between interval of convergence. 1 and 2 between interval of convergence, any numbers. 2 to 3 have an interval of convergence, and here is the point. 1 to 2 have interval, 3 to 4 have interval between interval of convergence, all numbers. So what is the radius of convergence? Every series has its radius of convergence. Radius of convergence means the horizontal line with numbers, the numbers or points. It means interval of convergence. Examples: if r greater than 0, then the series converges x minus a less than r, and diverges for x minus a greater than r. Here's the ending points. Okay. Remarkable points. X line is called radius of convergence if the series converges for only its center a, then r is equal to 0. If the series converges for all x, then r is equal to infinity. Recall the absolute value x minus a less than r is equivalent to the simultaneous inequality a minus r less than x less than a plus r up to so on. I hope that you understand very well. Short of time. Absolute convergence. So what is the absolute convergence in intervals? This is a very important topic in applied and pure mathematics. Here is the ending points, a minus r, a plus r. Here is the between points. The series converges absolutely between these points. Okay, this is the absolute convergence on graph. Okay. I hope you understand very well this topic, and thanks for watching my video, and today's lecture ends here. Okay, so let's go to the next our lecture on interval of convergence, because I have no time for next topic. Thanks for watching. Allah Hafiz. Take care.